Okay, so let us discuss traveling waves. Here is our wave equation. It is a second order partial differential equation. U is the displacement from the mean position. It is a function of both space and time, and v is the phase velocity. We will show that u will have the following form: any function of x plus vt plus any function of x minus vt. To prove it, let us define two new variables, q equal to x plus vt and r equal to x minus vt. Then the partial derivative with respect to x using the chain rule becomes del q del x del q plus del r del x del r. And these coefficients del q del x and del r del x are both 1. That means del x becomes del q plus del r. What about del t? Using the chain rule, del q del t del q plus del r del t del r. And these two coefficients, del q del t and del r del t, has the values of v and minus v. So del t becomes v del q minus v del r. Now we will use formulas 4 and 5 and find the first derivative and second derivative, and then we will substitute in the wave equation and show that u xt will satisfy the wave equation. So what about the first derivative? First derivative using the formula becomes del u del x equal to f1 dash q plus f2 dash r, where f1 dash is the derivative with respect to q and f2 dash is the derivative with respect to r. And what about del t? It becomes v f1 dash q minus v f2 dash r, where f1 dash q again is derivative with respect to q and f2 dash again is the derivative with respect to r. So what about the second derivative? Del square u del x square, it becomes f1 double dash q plus f2 double dash r. And what about del square u del t square? V will come twice, so we will get v square. f1 double dash is the double derivative with respect to q, and f2 double dash is the double derivative with respect to r. So there is a difference between del square u del x square and del square u del t square. This is because of the presence of v square. Now if I divide equation 9 with v square, then in the right hand side we will get f1 double dash q plus f2 double dash r, and we can substitute this value using equation 8. It becomes del square u del x square. That means del square u del x square becomes 1 by v square del square u del t square, which is the wave equation. That means we get the solution uxt as f1 as a function of x plus vt and f2 as a function of x minus vt. Now this is left going, this is right going. Why? Because to keep x plus vt constant, if I increase t, x has to reduce, so this is left going. And keeping x minus vt equal to constant, if I increase t, x also has to increase, so this is right going. So this is a combination of left going and right going waves. Example, we can give two examples. One is a periodic example. uxt is a sine k x plus minus vt. Kx plus minus kvt becomes kx plus minus omega t. So this is periodic wave. And another example, here again, to keep x plus vt constant, if I increase t, x has to reduce. So it is a left going wave packet. So it represents a Gaussian wave packet which is moving to the left. So to summarize, we have shown that uxt has the form f1 x plus vt plus f2 x minus vt, where this represents left going wave and this represents right going wave. So I hope you found it interesting, and thank you for watching.